Right, well, we did a customer's Comtron yesterday, one of two that he sent in. So today we're going to do one of our sets, and it's one sent in by our mystery benefactor Alan. So, that looks exciting. Another CB for you. It works but needs a tune-up. It needs a speaker and the wires are very short, so be careful removing the case. So it's a Midland 77095. If you remember, he kindly sent one for my friend Stuart, which was greatly appreciated. Jolly good. Well, yes, that all looks very satisfactory. We'll get it powered up, get the clipboard on the go, and see what it's doing. I can't be bothered to untwazzle all that. Right, I'll plug it into the test equipment. So we did the... also donated by Alan, we did the Kerno Beta 1100, excuse me, like the other day, which actually is the same but different. Probably comes out of the same factory, and actually, in my opinion, it works better. So it's got PA, so I'll plug the PA speaker in, and if I can find the equipment input, we'll plug that in as well. So we want a mic for this. So I think it's standard Cybernet wire. Put the soldering iron on, ready. Switch on, power supply, 13.8 volts, and it's already drawing 0.03 of an amp, which is interesting. Right, switch it on. Annoyingly, as you know, these start on channel 9. Let's have a look at where the transmitter is. Picture in picture on, showing on my monitor. Transmit, 3 watt scale. Oh, is it going to do that? We'll do the PA first. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. You get CB hiss coming through the PA speaker, which isn't ideal. We'll have to unplug that because it affects the test gears you just heard. The only nifty thing is it says PA on the display because that chip has that facility. Oh, spot on 3 watts. I couldn't say that, could I? And let's go to some other channels. Spot on 3 watts on channel 1. And spot on 3 watts on channel 40. Now then, it's 2781. Does it have low power? It doesn't have low power. What a shame. Back to channel 20. And it's 805 milliamps. Deviation, so we've got a problem with the deviation meter on this test set. Wallow. 1 2 1 2 1 2. Wallow. It says 1.5, but I'm not. We'll have to check it on another meter. VCO we won't be doing unless it plays up. Frequency we will be doing, and it is. Let's go over to the. Yes, it's done it. 2779038. Good grief. Right, we'll better tune the signal generator to the same frequencies for a fair test. I bet this worked really well. It's like between the channels, isn't it? But you don't know whether it's finger trouble or whether the crystal's dropped off. There we go. Let's see where we are. I think he said the speaker was... Yeah, the speaker's knackered, isn't it? Synod meter on, switch to the synod meter camera. The poltergeist moved the camera. Okay, for 12 decibel synod, got a respectable 0.85. Now I'm going to check we're in the right mode. That's EMF mode, that's PD mode. It's in ×1 and not ×10. So yep, we're in the right mode. We've not had them as sensitive as this for a few sets. 0.68. And for 20. 2.5. Squelch, this is where these are let down. Full squelch is 1.6 microvolts. I can just imagine driving around town with this. It'd be chatter, 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 bleh, and all those noises. And let's see where the minimum is. Set threshold. At least this one hisses. It's 0.15. Which is a bit too sensitive, to be honest. So no meter, no meter, no meter lamp, switch works, sockets work, that works, no speaker, no mic, and it sounds like the speaker's knackered. He says it's short leads, so there we go. Well, that's a good start. So yeah, it's basically working, isn't it? But it's so off frequency. What did he say? It needs a tune-up. Yeah, it does. These can suffer from dry joints, but this doesn't seem to be one of them. So here we go, we're being very careful. I'm being so careful I can't even open the thing. Wow, yes. Oh yes. What has that come out of? I'm intrigued. I know you're all intrigued. What was that once? A toy something, I think. That'll be going in the vertical filing cabinet. We'll get a new speaker in that. Well, let's see whether it'll go on frequency. It's annoying that this is minimum volume. It's just like the standby racket until you squelch it. Right, so we'll go back to the frequency counter and see whether we can pop this on frequency. So we've put this on frequency. We'll get there eventually. As close as we're going to get it. And we'll be coming to this, back to this anyway, because the test set's only been on 20 minutes. At least we can do all the tests now properly. Right, so let's go through the transmitter tune-up. So it's doing 3 watts exactly. Let's go over to that camera. We'll keep it in the 3 watt scale because it's really easy to see a very small deflection on the meter on the 3 watt scale instead of the 30 watt scale. With this being a test instrument, of course, for business two-way radio, it's a 30 watt instrument in the other range, because most business radios are going to be a maximum of 25 watts in the UK. It'd be really useful if it had a 10 watt range, but it doesn't. No, that's all tuned, so we'll need to get to the notes and adjust the transmit power, which I just seem to think is that one, but I may be wrong, and if I am wrong, well, I'll have to readjust. Is the power one, yeah. So let's just go over to the other scale. It's exactly 4 watts at that. I'll just check these two again. Pop that down a bit, it has changed it. Do about 4.3. We'll have it dead on the floor like that. Right. So it's now 4 watts on channel 20. Let's hope it's as well tracked on the other channels. Channel 40, I'd like to say is 4.05. So I expect channel 1 will be 3 point something. I'm right, it's 3.95. We could go backwards and forwards and backwards and forwards. I'm not going to. Right. We're not going to touch a deviation, because I say the deviation meter is not reading right on this test instrument at present. It does in the 5 kilohertz scale. Look at that. Wallow. When I put it in the right way. 1, 2, 1, 2. Wallow. We did a minute ago. Are we not on tune anymore? No, on channel 1, that's why. No wonder I can't get a reading. Back to channel 20. Wallow. So it's working fine on 0.5, but it's on the 5 watt scale. Wallow. It's reading not what I would think to be. I'll tell you what, I'm going to adjust it. I think it's that one, isn't it, on these? Wall. No, it won't even go. It won't even go. If I put it up to full whack, wallow. It says wallow. It says it says 1.6. Well, it's probably about 4 now. So we'll have to. I'm sure I'm not pressing any wrong switches. I'll have this test set long enough. 1, 2, wallow. 1, 2, wallow. 1, 2, wallow. Right. The trouble is, if we take the test set off here and sort it out, it would be months without it. So it's quicker to just use another instrument. Because there's only 40-minute sessions to do anything, we'd have to send back all repairs which are unrepaired, not take anything in, so we just have to carry on. We haven't got other benches set up for transmitters, only for receivers and for general electronics. Wall, yes, about 2, so it won't be right. So there isn't a low power setting, disappointingly. They're so short that I think we're going to probably... Let's just think about that. They really are short, aren't they? I don't like adding wires on. It's just seems a bit amateurish. Right. So we'll now go over to the receiver. We'll put the detector onto the oscilloscope. 100 microvolts on the signal generator. Let's have a look at the oscilloscope, even though I pressed it once. Turn the bench light off. Turn the volume down just a fraction, it's just a bit too loud. But I think we're going to have to centralise this position. There we are. So the detector coil on this is going to be that one. A little bit out. I'd be no good as a car mechanic, would I? Where, oh, I don't know, looked at this last, wouldn't be doing that. I said, well, actually, there was only one thing that was slightly out. We've gone through everything, but there was only one thing that was slightly out. Let's go over to the cyanide meter. Mind you, the cyanide meter built into the test set doesn't work, which is why we use the external one, so we seem to have gone the same way with the deviation meter. So at the moment I'm on the 1 microvolt scale. Just pop more volume on. No difference. No difference. No difference. No difference. No difference. So just put a bigger signal on. We'll look at these IF ones a bit more closely. See what we've got on the cyanide reading now. Let's go back. Right, so go over to the attenuator, see what I'm doing. So for 12 dB, we've got exactly 0.85. For 10 dB, we've actually got 0.7. And for 20, we've now got 2.4. So just doing the detector, it now looks like it's less sensitive, very minutely, but it isn't. It's got better clarity. Now, pesky squelch. The danger here is that it will end up, if we're not careful, with the squelch not opening when there's no error connected, and people don't think the radio's working. I'm going to turn it to full. Let's start with there. So that now gives us 7.5 microvolts. For tight. Which is about where you'd get a walkie-talkie, to be honest, but there you are. Okay, let's see where it is at the sensitive end. So does it hiss with no signal? No, it doesn't. This is what we're up against. People do not want a radio that doesn't hiss when there's no signal. So we're going to have to adjust it till it starts hissing. Which is there. It's only on the verge of it. I wonder if I take the aerial out. No, it does. It's still okay. So that's good. So we're going to get another figure, aren't we now? So set the threshold on the radio. There we are. It's still ridiculously sensitive at 0.15, but this upper figure will now be inferior in a moment. So I'll put the squelch back to full and see where it is now. It's 3.3. That's the best compromise. And this is the problem with these radios, and why the Kerno Beta 1100 we did yesterday is better in this respect. It doesn't make this a bad radio, but if you're in a city, it's just going to be... Squelch isn't ever going to squelch out, is it? It's just going to be sat there doing noise. And they're all the same. It's not faulty. So that gives us two things to do. Oh, we'll check the transmit current. Of course, we've got to unplug the extension speaker. That is frustrating. It's now 953 milliamps for another watt, which is good. So I've got to do deviation, and I've got to replace the speaker. So I'm going to go for my tea. I think we're going into town with Mr. Chippy. It's Friday. I think we go to the chip shop on a... Mr. Chippy and I go to the chip shop. How about that? See you in a bit. Right, so we're back from tea. It was kebab day, it turns out, today. With this, I've just come in and this test set's still been on, of course, and it seems to me the deviation meter's working at the moment. I just set it with the other one, but it agrees, so that's good. Let's just go over to that meter. Wallow, wallow. So that's peak. It's about 2.4. (2.1 to 2.4). No idea where it was before. So we've done the speaker. I had a used one, so that's there. Let's hope it works. Now, is there enough wire? There is enough. With it having the totally wrong speaker, the terminals were nearer the centre. So having the correct speaker, there's enough wire. I was beginning to think somebody chopped it off short, but they haven't. I was asked to regale the story of the phrase that I come out with sometimes, "I fixed it worse." So when I was doing my apprenticeship in church pipe organ restoration, that's not very good. Ideally, I'd chop that off and redo it, but I'm not going to because it's so short. So when I did my apprenticeship in church pipe organ restoration, it doesn't fit, does it, that way around? I've got to move the speaker. I was just off Carlton Road in Nottingham. It was Leighton Street, which was the gymnasium to a former school. They'd previously been on Carlton Road, Portchester Road corner, in a former wooden chapel. And because of road widening, it was compulsory purchased, and the council did a swap, and they gave the firm these alternative premises, which was a former school gymnasium, and the machinery was paid for to be moved. So let's see if that fits. I'll get this right eventually. Yes, if it's just there, it fits. So, having set the scene, there was various shops on the bottom road on Carlton Road. There was a Chinese takeaway, and I remember having the hardest fish cake I've ever had in my life. That's the breadcrumb type of fish cake for those people listening from Yorkshire, where they're not like that. And anyway, I read in the paper a week later, this a gentleman had been taken to hospital with a bone stuck in his throat. Now, I've had to go to hospital with a bone stuck in my throat once. It was a fish bone. And when the hospital, I was going to say, fished it out, in this gentleman's case, it was found to be a rat bone. So I'm just going by the by there. But amongst the shops was a shop that did service work to car alternators and starter motors. You know, you're going with, I had a Datsun 720 pickup truck, and the starter motor was a bit iffy, so I took it off, which is quite easy to get to, and I took it in for overhaul. I don't think they charged me 30 quid or something, and that was the end of the problem. But while I was in there, either waiting to be served initially or to collect it later, a gentleman came in with either a starter motor or an alternator, and he slammed it down on the carpet, on the counter, and he said, "You fixed this worse." So that's where the phrase comes from. I think it's absolutely fantastic. So they'd fixed it worse. See what I can tell you while we're putting a few screws in the radio. Right, this is going to be ready for a scratchy corner. So apart from, as ever, the funny squelch on it, it's not faulty, it's the way they are, which is dreadful. Right, we'll pop through the channels. We will do when we put an aerial on it. We'll turn the test gear off. One on a Roger. Right, bench cookie, and Mr. Chippy will no doubt be ready in the next 10 minutes. So, thanks once again to Alan for sending the set in. Tomorrow we're going to be doing Thunderbolt T3000. There seems to be a rumour going around that these things overheat. Now, we used one as a base station for a year, and it was on 18 hours a day. It didn't overheat. So, do they overheat if people exceed the recommended 5% transmit duty cycle? Or do they overheat if somebody tweaks them up to beyond legal limits? That would be interesting, wouldn't it? So, we're going to do the Thunderbolt T3000, and we're going to put in transmit a lot, and I'm going to have my temperature gauge fingers to see. I'll probably burn my fingers, not be able to play the organ on Sunday. So that's what we're going to do. Thunderbolt T3000, it's for the customer from Sheffield, and it's going to be the second of his 6 he sent in. So thanks for watching the Midland 77095 from about 1987.